Okay, so the notes today are a little review of factoring. And so this right here is the list of rules or the questions you should go through in your head as you're factoring to help you figure out what to do. This 6 things. So step 1 is pull up the GCF, the greatest common factor. Whether you can pull an X out of all of them or a 2 or a 3 or whatever, if you can pull out a GCF out of every single term, you want to do that. Then you should say if it's a quadratic, factor using quadratic methods that we reviewed earlier this week and late last week. If it's a funny quadratic, maybe try something special like one of the below. And if that doesn't work, then we can try a cubic, which is also below, sum and difference of cubes. And finally, we can try to take a trinomial and use a thing called use substitution. So from Algebra 2, and maybe even Algebra 1, I really hope you remember these very special factoring patterns right here. The first one is the difference of 2 squares. That's something like maybe x squared minus 9, and that would factor into x plus 3 and x minus 3. And then the sum of difference of cubes, we'll talk more about when we get to those examples. But the bottom line is that you need to be able to recognize special factoring patterns. So when you're stuck or you think you're stuck, you're like, I don't know what to do, you definitely should be able to look and see, oh, I could definitely use a special factoring pattern to help me factor this object. So I know that down the rest of this page in your notes, all the problems are worked out, but I'm going to work on each of them and explain them to you and hope that helps you. So our first problem says x squared minus 4. This is one of those recognized special factoring patterns. Because we have 2 terms, we have a binomial, 2 terms, and they're both perfect squares, this is going to factor into the a minus b, a plus b, because it's an a squared minus a b squared, 2 perfect squares. A is going to be equal to x in this case, and the square root of 4 is 2. So my b is going to equal 2. So then we plug these in right here to our special factoring pattern. And instead of saying a minus b, we say x minus 2, x plus 2. Just so you know, that's the same thing as saying x plus 2 and x minus 2. Same exact thing. Okay, the next 2 examples go together. The first one says, I'm going to put them down here, x cubed plus 27. And the other one says 8x cubed minus 125. So if you have a cubed plus b cubed or a cubed minus b cubed, this is the sum of cubes and this is the difference of cubes. What we need to do is we need to state what a and b are. So you take the cube root of each of them. So the cube root of a cubed is a and b. And the pattern for both of them goes a, b, a squared, ab, b squared. Same thing here. Cube root of a cubed is a, cube root of b cubed is b. Same exact pattern. They're exactly the same. A, b, a squared, ab, b squared. The thing you have to remember is same, opposite, always positive. So I'm going to write it in the middle. Same, opposite, always positive. And this is for the signs. So my sign here was a plus. So same sign, opposite sign, always positive. And then the next one, the sign here is a minus. So same sign, opposite sign, always positive. So let's try this. Cube root of x cubed is x cubed root of 27. So what times what is 27? It's 3. So we're going to use our pattern, and in this case, it's going to be A is going to become an x, and B is going to become a 3. And then this would be x squared, 3x, and B squared, 3 squared is 9. So this was a plus. Same, opposite, always positive. This is your answer. On this one over here, we take this whole thing and we cube root it. So the cube root of 8 is 2. Cube root of x cubed is x. Cube root of 125 is 5. So we're going to do a, b, a squared. Be so careful. A squared is the whole thing squared. So 4x squared. A times b is going to make a 10x, and then a b squared is going to make a 25. Same minus, so same, opposite, always positive. There you go, right there. So there's your sum and difference of cubes. The back side is the one that's a little bit new and different, just a little bit. So let's try the next problem. Okay, so this is a quadratic looking thing. Oops, said quadratic, I didn't even write the problem right. Let me try that one more time, sorry. This is a quadratic looking thing, but it's not a quadratic. It's what we call a quartic because the highest degree is a 4. So this looks like something familiar, but it's a little bit different. And here's the key. When this power times 2 makes this power, we use what's called a U substitution. So what I'm going to do is I'm going to let U equal x squared, and then U squared is equal to x squared squared, or x to the 4th. I'm going to rewrite my problem. X to the 4th is called U squared, minus 4, x squared is now just called a U, minus 45. This is now an Algebra 1 problem. This is just a basic factoring problem because my leading coefficient is a 1. If this were a number up here, like a 9 maybe, then I'd have to do this a times c thing. But bottom line is this makes my very big 4th power quartic go back to being a quadratic, something I can deal with. This 9 wasn't here, okay. So parentheses, parentheses. 2 factors of negative 45 that add and make negative 4. So u minus 9 and u plus 5. Now you have to replace. We didn't have u's, we had x's. So I had x squared minus 9 and x squared plus 5. The x squared plus 5 doesn't change. But this right here, my friends, be very careful. This is a great place for difference of squares to hide. This is a x minus 3 and a x plus 3. It's the difference of 2 perfect squares. And this is your final answer. Let's try another one of these. Okay, so I'm making up a problem. Let's try to factor 3a to the 4th plus 17a squared minus 6. So again, I have this difference of powers where I take this one and I multiply by 2, and that gets me to this one. So I'm going to do that U substitution thing. I'm going to let U equal a squared. So U squared would be the same thing as a to the 4th. 3u squared plus 17u minus 6. Now this is not just factor. You have to do that AC method, or if you like the box method, you could do that. I prefer factor by grouping. So 3 times negative 6 is negative 18. I need 2 factors of negative 18 that add up to make 17. So I'm going to do 18 and 1. And the 1's going to be a negative. So I'm going to write down 3u squared plus 18u minus 1u minus 6. Now you make 2 groups. The first 2 are a group and the second 2 are a group. My first 2 are going to have, give me 1 second, I'm going to make this a little bit smaller. So my first 2, my yellow group, they have a 3 and a u in common, and you're left with u plus 6. My red group has a -1 in common, and then you're left with u plus 6. Personally, the reason why I like this more than any other method is because I know what I'm doing is right. Because the things in parentheses have to match for this to be working and doing it right. So in my yellow and my red group, I both have a u plus 6. In my yellow group, I'm left with a 3u, and in my red group, a -1. So this is my factored version, but again, you have to go back and replace what you had. I didn't have u's, I had a's. So now I have a squared plus 6 and a 3a squared minus 1. This is not a perfect square. So in the last problem, because it was two perfect squares, the difference of two perfect squares, I could factor again. But since it's not this time, this is my final answer. Let's go back to our, let's try the next one that says x to the 4th minus 81. Okay, you can use u substitution, too many u's in a sentence. Use u substitution, or you can see that this is a perfect square and a perfect square. The square root of x to the 4th is x squared. The square root of 81 is 9. So this is my a and my b, and I'm going to do that whole a plus b, a minus b pattern. So I get x squared plus 9, x squared minus 9. And I'm going to be so careful right here because that, my friends, is the difference of two squares again. So this becomes an x squared plus 9. And then this underlined piece becomes x squared. No, not an x squared. Try again. Becomes an x plus 3 and an x minus 3 because it was two perfect squares. So that's my final answer. Okay, let's try another one. From your notes, it says that you have x minus 2 squared minus 9. Now, this is one where I would definitely use u substitution. Let's let u equal x minus 2. So instead of writing x minus 2, I can write u, and then it's squared, minus 9. This is the difference of two perfect squares, a, b, or in our case, u and 3, a plus b, a minus b. So this becomes u plus 3, u minus 3, and then I need to replace. I didn't have a u. I had an x minus 2. So I have a x minus 2 plus 3, and then I have an x minus 2 minus 3. And you can clean this up one more time. And you can call this x plus 1 and x minus 5. Let's try another one of the u substitutions. Let's try, let me make one up. Let's try this one. Let's do 8 a minus 3 squared plus 36 a minus 3 minus 324. And I know many of you are like, what is that? Oh my goodness. I'm going to let this whole thing right here become my u. Well, actually, I'll make this thing my u. So then this is my u squared. So if I let u equal a minus 3, then u squared is equal to a minus 3 squared. So now what I really have is 8u squared plus 36u minus 324. So let's check a little bit of thinking and math. I know that 8 goes into 36. Let's make sure that 8 goes into 324, which I'm pretty sure it does. Oh, does it not? Oh, it does not. Okay, I can't pull 8 out of everything. Let's see, what can I pull out of everything? Maybe a 4? A 4. Let's try a 4. So I'm going to GCF and pull a 4 out. That leaves me with 2u squared plus 9u minus 81. 2, 9, and 81 don't have anything in common, so everything I've done so far is about as much as I can do as far as GCF factoring. So now I can't drop this 4. I gotta hold on to the 4. But I'm gonna factor this from the parentheses. So my 4 is gonna chill out front. Parentheses. Okay, so 2 times negative 81 is negative 162. We need two factors of negative 162 that add up to make my 9. So here's a really cool fact. If you take the digits of a number and add them up, so my 1, my 6, and my 2, 1 plus 6 plus 2 equals 9. If the digits of a number add up to something that is divisible by 3 or divisible by 9, then this number is also then divisible by 3 and divisible by 9. So 1 plus 6 plus 2 is 9. So that means 9 goes into 162. Fun fact. It actually goes in 18 times. So I'm going to rewrite this as 18u and a negative 9u. 18 times negative 9 make my negative 162, and 18u plus 9, negative 9u, make my 9u up here. So I have 2u squared plus 18u minus 9u minus 81. And then I'm going to do that group thing like I did earlier with my my yellow, my red, yellow group, red group. Again, I'm not dropping that 4 out front. He's got to keep coming along for the ride. So I got a 4 parentheses. In my yellow group, they both have a 2u in common, and I'm left with a u plus 9. In my red group, they both have a negative 9 in common, and I'm left with a u plus 9. Inside of my parentheses, 4, these both have a u plus 9. So I'm going to do a u plus 9 times a 2u minus 9. Oh, goodness gracious, that was a lot of work. Okay, here we go. Let's finish this problem up. I didn't have a u. I actually had right up here that u was equal to a minus 3. So 4a minus 3 plus 9 times 2a minus 3 minus 9. Okay, 4a plus 6. These two make a 6. The 2's got to get distributed in. So I got 2a minus 6 and then minus my 9. 4a plus 6. 2a minus 15. That was a great problem. So many things involved. U substitution, factoring with a leading coefficient, pulling out a GCF. That is a great problem. So there's lots more practice posted for you that you can go try. And if you need some help, your pre-cal teachers are all here to help you. You can come ask any one of us for some help.